Thank you, and good evening, everybody. So yes, first eye on the sky, a rough guide if anybody out there is interested in buying their first astronomical telescope, either for themselves or perhaps for a younger member of the family. So I'll be talking about buying a telescope. I'll be talking about how different telescopes differ from each other, effectively looking at pros and cons. I'll be looking at not only the telescopes, but how the telescopes are mounted. It's quite important not only to think about the telescope itself, but the stand, the tripod, the mount on which the telescope is placed that allows you to follow the stars in the sky as the Earth slowly rotates once a day. So I'll be asking, why is one telescope better than another? More expensive ones sometimes are better than cheaper ones, but not necessarily. And I'll be looking at the prices. And I have a number of handouts here, so you don't have to make notes as you go along. If anybody is actually interested in the sort of prices that you are expected to pay for telescopes, I've got handouts of the talk, the slides of the talk, and of the prices as well. So you can use that, refer to those later if you wish. And I'll finish by giving a few hints and tips, things that you ought to think about before letting go of your hard-earned cash, before handing it over to somebody and buying a telescope. So the most common question is, I've got a son, daughter, grandson, granddaughter, niece, nephew, and they're interested in a telescope. Which telescope should I buy? And that's almost impossible to answer, except that you don't necessarily buy the cheapest one that's out there, because the cheapest one that's out there is probably not a real telescope in the sense of the word. But there are telescopes that look like they might be toys, but actually are still half-decent telescopes. So it is difficult to judge what is something that is certainly a toy and should be avoided versus an entry-level telescope. And there are resources to guide you. For instance, on the web, there's some very nice brochures, if you like, flyers, documents, call them what you will. There's lots of help out there. And there are some guides which I would say are very well written, in the sense they guide you to the different types of telescopes and what you ought to look out for, why one telescope differs from another. But bear in mind, some of these guides, including this one that I just happen to have with me, is made by a telescope manufacturer. So they, of course, are going to be giving you examples which are their own telescopes. They won't be telling you about their rivals' telescopes. So bear in mind, please come in, take a seat. Bear in mind that if you're reading a guide written by a particular manufacturer, don't expect it to be completely broad in terms of what they're advising. This particular one, I've got no affiliation with Celestron. They just happen to be a manufacturer of very nice telescopes. And this particular guide, and I can point you to where on the web you can find this. I haven't got many printed copies, but I can point you to where they are. It's very nice because it tells you literally the basic features of telescopes, what to look out for, why a telescope with lenses is different from a telescope using mirrors, and the sorts of things that you might want to look out for, including what sort of accessories you might want to make the most of your telescope. And before a telescope, you might want to think about, is it worth a pair of binoculars before you invest any more money on a telescope, for instance. But when it comes to making a decision, you might say, well, I'll just get myself a catalogue from a manufacturer that sells lots and lots of different types of telescopes. But this particular catalogue is 83 pages long. And just to give you an idea, here's some of the pages of this particular catalogue. And if you were to flick through the pages, you would say, okay, there's a few telescopes there. Some appear to be red, some appear to be blue, some appear to be black. I've got no idea if the color matters. But as soon as you start flicking through the pages, you realize that there are lots and lots and lots and lots and lots and lots of telescopes. Even before you start saying, well, there are at least half a dozen different manufacturers, there are literally hundreds, if not thousands, of different models, different sizes, different capabilities of telescopes. So it is not altogether surprising that if you flick through a catalogue like this, either a paper catalogue or the equivalent on a web page, it is very, very easy to get confused at the sheer choice that's available to you. How do you make a decision as to whether this telescope is better than that telescope? You could argue you need to do a little bit of homework and find out what can this telescope do, what can that telescope do, but it's far better to find somebody who knows and ask them. For instance, there are members of Liverpool Astronomical Society up on the 5th floor at the moment. If you are seriously interested in doing something about buying a telescope, the best thing to do is to have a chat to somebody who knows about these things. You can find the information out there, but like most topics, there's so much information, you've got to be careful. And again, it's not just telescopes, it's accessories, eyepieces, etc., and all sorts of other things that you might be interested in buying. Telescopes themselves come in all shapes and sizes. The one on the left is perhaps what most people think of when they think of a telescope: long tube, a lens at one end, an eyepiece at the other end. Regardless of whether it's sitting on a very sturdy mount like this, you would never handhold a telescope, unlike Nelson on a ship, looking for ships in the distance. For astronomical purposes, we would always put the telescope on a very sturdy mount. But some telescopes use lenses. Don't worry about that fancy word there. That just means some telescopes use glass to refract the light, to bend the light, to form an image. Some telescopes use mirrors, and again, don't worry about that word. They're just mirrors to reflect the light and form an image. And even more confusingly, there are some telescopes that actually have lenses and mirrors, so you've got to think about, again, pros and cons. These ones in the middle here, let's just give them their simplified names. Nobody actually uses that label. Everybody calls a telescope that has glass to form an image, lenses to form an image, we call those refractors. Any telescope that uses mirrors to form an image, we call those reflectors. And some telescopes use lenses and mirrors, and we call those cats for short. So they all have their own advantages and disadvantages. Let me just tell you how they differ in terms of how they form images, then I'll tell you about the pros and cons of different types. So this is the classic sort of telescope in which there's a lens at one end and an eyepiece at the other. So the lens takes the light from a distant object and focuses it down to a point, which is then looked at with an eyepiece. So the light comes out of the eyepiece, and that's where you place your eye to pick up the light that's been collected by the telescope. The lens itself will not just be a single piece of glass, because that tends to produce colors. Just like light traveling through a prism will be split into a rainbow of colors, the same would be true of a single lens. So although you might get a nice view of Venus or the moon, you'll also get a whole load of colors around the edge, because it won't focus all colors perfectly. So most astronomical telescopes will have not a single piece of glass at the front end, but multiple pieces of glass of different density, so-called different refractive index, and they will help mitigate this color fringing. It'll help reduce the amount of color fringing to give you a nice crisp image. But unfortunately, the more glass you put in here, the more lenses you put in here, the more expensive. So generally speaking, the more you pay, the higher the quality of the images you're going to be looking at. One way of getting around the problem of lenses splitting light into colors is don't use lenses to collect the light. Use mirrors instead. This was figured out by Isaac Newton 400 and some years ago. So if you use a mirror to reflect the light to a point, well, you can perhaps see the problem that if you wanted to put an eyepiece here and look through an eyepiece, your head would block the incoming light. So that's no good. So Newton figured, well, what should I do? He figured, let's put a mirror in, a little flat mirror into the tube, and then send the light out sideways, so the eyepiece is actually on the side of the tube, not at the front, not at the back, but on the side. And we can see that sort of telescope here, a long tube with a mirror at this end, which you can't see, and the eyepiece is sitting on the side because of this flat mirror sending the light out sideways. So that gets around the problem of lenses producing a whole load of colors. You get very nice crisp images from this type of telescope. It's not the only way of using mirrors. Again, a few hundred years ago, it was realized that there are alternatives. And one suggestion was, again, you bring the light to a focus, but now you put a small hole in the main mirror. That seems a little bit odd, but the reason for putting a hole in the main mirror is before the light comes to a focus, you put another mirror in there and send the light back again. So the light is sort of folded in this tube. That's the design of the Hubble Space Telescope, for instance. It might sound a bit odd, but the idea of having two mirrors and a hole in the first one, that's used by a lot of different telescopes. If it's good enough for the Hubble Space Telescope, it's good enough for amateurs as well. And it also has the advantage that even though the focal length, how far it is from the mirror to the focus point, which determines the magnification of what you're looking at, you don't necessarily need a very long tube, even though you've got a relatively long focal length, because it can be folded up like that. Other designs use a different shaped mirror and use a piece of glass on the front. I'm not going to go into the details of why that optical design is preferred, but it's using mirrors to focus the light, and it looks like a plain piece of glass. It's actually a piece of glass which is focusing ever so slightly, and that's this particular type of telescope where you've got a mirror at the back and a piece of glass at the front. So it's one of these so-called cats, because it's a combination of using glass and using mirrors in the telescope. Another type, which is, let's not worry about the name, that's just the name of the person who first came up with this idea. It has a curved piece of glass at the front, and perhaps you can see in this particular example here, the front piece of glass is actually dish-shaped. So you can recognize this particular design of telescope by just looking at what that front piece of glass actually looks like. So we have telescopes that use lenses, telescopes that use mirrors, and telescopes that use a combination of the two. But as I've said, because we live on an Earth and Earth is rotating once a day, that means the stars appear to move throughout the sky. You may think they don't move very fast. It takes ages for the stars to go from one horizon to the other horizon. Well, true enough. But if you're looking at some detail on the moon, or you're looking at some detail on Saturn, it's not long before that will drift out of your field of view if you're just placing your telescope on a static mount and pointing at one bit of sky. You don't notice the Earth's rotation until you're looking at objects in the night sky. So when you think about a telescope, you also have to think about how is that telescope going to be mounted in such a way that I can point it to different points in the sky, especially points that are moving. And there's lots of different so-called telescope mounts, lots of ways of putting telescopes onto usually a tripod, but not always a tripod, such that you can move them to any part of the sky. One of the simplest is called altaz, because you can move the mount in altitude, up and down, and you can move it in azimuth, back and forth, left and right, rotating. You can see that all of these have the same basic idea. The telescope tube can move up and down, and it can rotate on its tripod. It can move up and down, and this fork mounting can rotate on its tripod. Some altaz, altitude azimuth mounts, are motorized. You don't have to have a motorized mount. You can just move the thing yourself. The easiest way, the cheapest way of getting a telescope on a mount is literally to move the telescope and point at the object you want to. But some people prefer to have motorized mounts, and generally speaking, motorized mounts will be a little more expensive. And if you want also to have a computer in control, i.e. I would like to be able to point at a particular object without knowing where that object is. If you don't want to learn your way around the sky, you can also have a computer point the telescope for you. But the more it can do, the more you pay. The simplest one is one where you move it yourself, nice and cheap. The more functionality you want in the telescope and in the mount, the more you will end up paying. Some telescopes are mounted on axes that look very odd. Why would you want a telescope that doesn't just move up and down and left and right? Surely that's the simplest thing you can have. Why would you want one that moves on axes at such a jaunty angle? Well, you might want a mount like this because we live in the United Kingdom and we are 52-ish degrees, 52, 53 degrees north of the equator. So when we think about how the Earth rotates and spins on its axis, and that axis is pointing to the North Celestial Pole. It's a point in the sky directly above the North Pole. So if we live in England, which is sort of halfway between the North Pole and the equator, you can see that the Earth isn't rotating about an axis which is vertical, and it isn't rotating about an axis which is horizontal. It's at a jaunty angle. So if you set up your telescope at that same angle so that your telescope is lined up with the Earth's axis, that means as the Earth turns, you only need to turn one axis of the telescope to keep tracking the stars. In other words, because the Earth spins on one particular axis, if you can line up your telescope on the same axis, it simplifies following objects in the sky. If you think about objects like the moon rising in the east and then going south and then setting in the west, if you had an altitude azimuth, an altaz mount, you would have to raise it to start with and move to the right, and then it would go south, and then you would start to lower it. You have to move on both axes. So this particular system, called an equatorial mount, simplifies the motion of the telescope. A lot of people that start thinking about astronomy and buying telescopes often are interested in astrophotography. In other words, what would I have to do, not just to see these objects, but to photograph these objects? Astronomy photography, astrophotography. In principle, one option is take out the eyepiece that you're using to look into the telescope and replace it with what you might call an electronic eyepiece, a small camera that effectively images what you would otherwise see through the telescope. Telescopes with relatively long focal length, in other words, a long distance between the lens or mirror and where the light comes to a focus. Relatively long focal lengths are good for seeing very small objects, so detail on the moon or the rings of Saturn or the belts on Jupiter. So great for bright objects like the moon and the planets. Deep sky objects is the collective name we give for very distant and much fainter objects, distant nebulae, clouds of gas in the sky that are forming stars, or distant galaxies. Altogether fainter, and so you need much longer exposures. To take an image of the moon, you might only need a tiny fraction of a second, and it's done. But if you want to photograph a very distant object, you might have to expose for seconds or minutes. Some amateurs might take photographs that effectively last for hours to collect that faint light to give you a nice image. So some astrophotographers will buy dedicated cameras, and it starts to get very expensive. Shelling out money not just for a telescope, spending money not just on a mount that allows that telescope to point to the sky, but also shelling out money to buy cameras to allow them to do astrophotography. But I would argue that that's not really necessary if you've already got a camera. If that camera is used to take pictures at birthday parties or weddings or your pet dog, it doesn't matter. If it's designed to take daylight, amazingly enough, it would probably also work very nicely to take pictures of the night sky. I'm not, in this talk, going to go into the pros and cons of different cameras, because this talk is mainly about telescopes rather than about astrophotography as such. I'm giving another talk at 7:15 about astrophotography up on the next floor if anybody is interested. I would argue that you do not need a telescope if you're interested in astrophotography. So don't conflate the two ideas. Don't assume that if you want to take pictures of the night sky, you must buy a telescope. That's the only way of taking nice pictures of the night sky. That is not true. I am quite a keen photographer. I like to take pictures of animals. I'm quite keen on wildlife photography. So I've got a camera that's designed to take pictures in daylight. But I have found that that same camera can actually take rather nice images of the night sky. All of these images here shown, these 6 images, were taken by me without using a telescope. That's just using a camera and a lens, perhaps a wide-angle lens, perhaps a telephoto lens. But these objects, these star-forming regions, this distant galaxy, this supernova, this star that has blown itself to pieces, the Milky Way itself, all of these things can be taken with a camera as long as you take into account the motion of the sky. So yes, astrophotography using a telescope can be fantastic. There are amateurs that have taken incredible images by taking an amateur telescope, attaching a camera, and then taking really fantastic images. But beware, astrophotography using a telescope will take time to learn how to do it, and it will take some effort. You won't be up and running in 5 minutes. And most importantly, it will take cash. You will need to spend a non-trivial amount of money on the telescope, on the mount, on the camera. I would argue you can do it much more cheaply just by using the camera you've already got. More about that at 7:15 up on the next floor, the talk on astrophotography. So let's come back to telescopes. If you're interested in buying a telescope, here's the basic types I was showing you before. What are the pros and cons of either a refractor or using a mirror in a so-called Newtonian telescope? Dobsonian is just another name for a Newtonian in a very cheap mount. And on the left-hand side, we've got 2 different types of cats. We don't have to worry about their names. The names just refer to how the light is focused in those telescopes. So what are the pros and cons of buying one rather than another? Well, I've already said that if lens is used to focus the light, lenses can produce false color. They can produce, for instance, an image of the moon or Venus or Saturn in which you get color fringing around the edges because a lens will never focus all colors of light perfectly. It's called chromatic aberration technically, but it doesn't matter. It just means color fringing. So one way of getting around that is to spend even more money on a better lens in your telescope. Alternatively, use mirrors rather than lenses. So that's why Newtonian telescopes are quite popular, because mirrors don't suffer from this same color fringing. A Dobsonian is just the name given to this particular type of telescope on a very simple Altaz mount, very good for just pointing at objects in the sky. Long focal lengths, the focal length is just the distance between the lens and the mirror, or the mirror, and where the light comes to a focus. If that focal length is quite long, not just a few centimeters, but half a meter or more, if it's a nice long focal length, you get wonderful views of the planets and the moon. And the advantage of these on the left-hand side, these cats, is because the light is folded, if you remember those diagrams earlier, because the light is folded, you get actually quite a long focal length, but in a relatively compact tube. So it makes life easier in terms of the physical size of the telescope. Large apertures are good for faint objects. If you've got a faint object out there, you want to collect as much light as possible. So the larger the lens, the larger the mirror, the more light you can collect, the fainter objects you can see. So large apertures are very good for deep sky objects, nebulae and galaxies. You could argue that you don't really need huge telescopes if you're looking at the moon or the planets, because they're quite bright. But if you're looking at a galaxy millions of light years away, ideally you want to collect as much light as possible, and that has the advantage of these larger apertures here. The largest aperture for a given price, in other words, some people would argue the best value for money, literally just what's the largest mirror I can get for the minimum outlay of cash. You could argue that the Dobsonian telescope is one of the best value for money. Just as a point of maintenance, these telescopes on the left are sealed in the sense that there's glass at one end and an eyepiece at the other, so dust and spiders can't get in, and therefore it's easier to maintain. Whereas a Newtonian telescope, it's got a mirror at one end and it's open at the other. So you've got to make sure that dust and small furry creatures don't get inside your telescope if you're leaving them outside. Portability is an issue. It's not just a question of what can I afford to buy in terms of which telescope is best for me. In some cases, it's a question of, well, I'd really like a big telescope, but I'll never lift it. Or I haven't got a car, so I can't just put the telescope in the back of the car and drive away from my estate where there's lots of street lights in order to get out into a nice dark part of the countryside to admire the dark sky and get away from light pollution. So the physical size and the weight of the telescope might be an important consideration. So I'm not going to spend too long on this, but this is just my attempt to summarize what sort of telescopes might you be able to buy for what sort of outlay of cash. So there are different types of telescope, a refractor or a Newtonian, etc., or these cats. And here indicated is how large a lens or mirror could you buy for a given amount of cash. So you can see that just by looking at the size in 3 inches, 4 inches, 5 inches, every telescope has a different price range because manufacturers find it easier to make these and more difficult to make those. So you can't assume that a telescope of a given size will be the same cost regardless of which type of telescope it is. So given that there's lots of options there, I'm not going to embarrass you by asking you how much cash have you got in order to buy a telescope. But some people would say, if you've only got less than £100, don't even think about buying a telescope. Go for a good pair of binoculars instead. So if you're in this region, don't think about, well, that telescope's only 75 quid, I'll go for that. You're far better off getting a good pair of binoculars and using those rather than a very cheap telescope. Some people would argue, if you look on the web and Google, what's the best telescope? Where's the best telescope to begin? What is a good beginner's telescope? Some people will say a Newtonian is the best starting telescope, and they will start at about £200 or so. Other people will argue, well, if you go for a Dobsonian, remember that's a Newtonian telescope on a very simple mount, That's the biggest aperture for a certain amount of outlay, and therefore you can get a larger mirror for a little bit more in price. You get a much larger mirror, and hence you can see fainter objects. I would argue pretty much anything in the blue rectangle is worth having a crack at. So, okay, I can't tell you what your budget is, but I don't think you'll go far wrong if you pick something somewhere in that blue rectangle. There are other web pages that say, no, don't do that. You want to go for something like an 8-inch telescope or whatever. Well, that's great if you've got the cash, but I'm not suggesting that you have to outlay £700 before you get to a beginner's telescope. The last thing you want to do is to buy an expensive telescope, find you don't use it, and then realize you've wasted your money and throw it on eBay. Remember, if you're interested in astrophotography, you don't even have to think about anything up here in the top right, because if you wish, you can get yourself a star tracker. A star tracker is basically a motor in a box that allows the camera to track the sky and allow you to take long exposures. So you can do astrophotography by starting with a star tracker, which costs almost nothing if you want to build one yourself. If anybody's interested, that's how you build yourself a star tracker for perhaps a few tens of pounds. So you can build one for yourself, you can do a DIY job, you can get clockwork star trackers, you can get motorized star trackers. But if you want to get into astrophotography seriously with a large telescope, you will need a rather more expensive equatorial mount, one that precisely follows the sky, and then you're talking about motorized mounts which are hundreds of pounds, and if you want it to be computer controlled so that it decides that's where this galaxy is, that's where this nebula is, rather than you figuring out where things are in the sky and learning your way around the sky, then you can see things start to get very expensive very quickly. So a few hints and tips, as we've got to wrap up in the next 5 minutes. You can't go wrong if you stick to one of the big manufacturers. I have no affiliation to any of these, and they're not given in any order other than alphabetic. These are the big manufacturers that are available in the UK. If you get a telescope from one of these manufacturers, you won't go far wrong. When it comes to buying a telescope, you've got a number of things to consider. How big is the lens or mirror collecting the light, and how long is the focal length? It is the aperture that really matters. That will determine how faint an object you can see. The focal length will determine the magnification, but magnification isn't anywhere near as important as you tend to think. As long as it's nice and clear, it doesn't matter. There's no point in magnifying an image which isn't clear. It'll just be, instead of a small fuzzy blob, a big fuzzy blob, and you still won't see any more. So magnification doesn't really matter. When you buy a telescope, you'll probably get 1 or 2 eyepieces that have different magnifications, and you can decide later if you want some different eyepieces. But remember, magnification, don't even worry about that to start with. Ergonomics, it does matter how big the telescope is. Is it going to be small enough to carry? Are you going to have a problem moving it outside into the garden? Are you going to have a problem transporting it to a dark sky site? And I've already said for astrophotography, if you're only going to be looking at objects, it doesn't matter if it tracks the sky perfectly, but if you're dealing with astrophotography, then it does matter that you track accurately and you need to invest a little more money. Do you want to be in control of what you're looking at, or do you want the computer in the telescope to decide that? Do you want to decide, I want to see this object and that object, or are you happy just to ask the telescope, show me an object that you think is interesting? Do you want the telescope to be in charge, or do you want to be in charge? It's your choice. You can have a computer in there if you wish, or you can take control of it yourself. Perhaps one of the most important pieces of advice is try before you buy. In other words, if possible, if you're really interested in this, latch on to an astronomical society, such as Liverpool Astronomical Society up on the 5th floor at the moment, and ask them for advice. That's especially true if you think you found a bargain on the internet. If you think you found somebody claiming to have a £2,000 telescope which is being sold for £200, if it sounds too good to be true, probably is too good to be true, take advice before you give up your hard-earned cash on something like that. Try and avoid the urge of buying something and then throwing every conceivable accessory at it. Some people like to tinker, and some people like to buy a telescope and then add another one onto the side, and then a camera, and then a few bits and a few bits. Some people take it to extreme until they run out of cables. it is tempting sometimes to get involved in the tech rather than the beauty of the night sky. Are you interested in what's out there in the universe, or are you interested in playing with toys that will allow you to look at the universe? Whenever you look in a catalogue, or indeed even more so on the web, be very wary when you're looking at different telescopes. You look at these two telescopes, one might be very much cheaper than the other, and you might wonder why, until you realize they're not being shown to scale. That is what they actually look like when they're shown side by side. One is much bigger than the other, but when you're looking at the pictures on a web page or in a catalogue, that might not be so obvious. So you have to ask yourself, it's not just a question of big apertures, big telescopes are better for collecting more light. You've got to ask yourself, is a small telescope really suitable for me? I'm not going to be able to kneel down and look through that one. I'm going to have to put it on a table or something much higher in order to use it. But if you're buying it for a 5-year-old, well, maybe that is more suitable for a youngster. You have to consider who it's being used for. Larger apertures, generally speaking, are better for collecting more light. But bear in mind, it makes a huge difference to the mass of the telescope. It might be very easy to pick that up and take that into the garden. For some people, 24 kilograms is not an option. If it's sitting in the, I don't know, the kitchen, the dining room, and you have to take it through the French doors into the garden, maybe you just say, oh, I can't be bothered, it's just too heavy. So think about how much mass is there. This is perhaps a little bit facetious, but basically just make sure you know what it is you're buying. Make sure you know what it is before it arrives. Yep. Okay. So for instance, that telescope might look fantastic, and you might look at it and think, wow, that is a superb telescope. I want one of those, and you might decide to buy it. But then when it arrives, you realize, well, actually, it's a bit bigger than I thought. And yes, that is the genuine size of this particular telescope. And yes, that is the mass, 300 kilograms. It weighs 1/3 of a ton. Now, the manufacturers of telescopes like that realize that that is very heavy, in which case they will do the decent thing, and they will ensure that that's balanced out by the fact that your bank balance afterwards is a lot lighter. These things are certainly not cheap. So the bottom line is your options are many and varied. There are lots of options as to what you might go for. So having lots of options is sometimes good, but lots of options is sometimes bad, because you just cannot choose which you're going to go for. So don't suffer from analysis paralysis. Look at what you can afford, take advice from people who know about these things, make a decision, and then enjoy your stargazing. Make use of resources of, for instance, astronomical societies, i.e. the people. They're the best people to go for. The web can give you a lot of specifications and information, but for advice, go to people rather than web pages. So what is the best telescope? Some would say there's no such thing. Other people say, yes, there is such a thing as the best telescope. The best telescope is the one you end up using, rather than the one that ends up gathering dust. Thank you very much for listening.